In Chapter 13, we're going to be looking at different types of mixtures. Now, we're not going to spend time looking at the whole um, unit or the whole Chapter 13. There's just a few things we need to review and a couple of new things that we'll need in chapters that we'll look at later. So, first of all, if we're looking at mixtures, we remember that mixtures are a blend of two or more substances that they aren't chemically combined. They keep their own properties and you can separate them. Sometimes it seems like it would be very difficult, but you could separate them and get them back into their own unique um, separate states. A heterogeneous mixture is going to be a mixture where you can see the different substances that are mixed together. So we can see different colors of M&Ms, so this will be a heterogeneous mixture. Whereas a homogeneous mixture, you cannot visibly see the different substances that are mixed together. So if we've got blue Kool-Aid, we know that there's sugar and water and Kool-Aid mixed, but they're not chemically combined. So technically, we could separate those apart. A solution is just another way of saying a homogeneous mixture. If something's soluble, it can be dissolved in another substance. So sugar would be soluble in water. Oil would not be soluble in water. Here we have what's called a solvent. And a solvent is a part of the solution, one of the substances that you're mixing together that actually dissolves the other. So if we're making Kool-Aid, the water is the solvent. And a lot of times you'll find that water is the solvent. It's going to be dissolving something else. A solute is the substance that goes into the solution and gets dissolved. Usually, this is of your substances the one that you have the lesser quantity. So here, the Kool-Aid is the solute. When we're looking at types of solutions, you're really just looking at what state of substances you're combining. So you might have two solids you're mixing together. You might have two liquids. You might be putting gases into liquids. An example of this would be when they put CO2 in soda. Like when you're going to get a fountain soda and they've got the CO2 tanks and they're pumping that in, that would be a combination of gases and liquids. And so here are some several types. Gases and gas, if they're using um, air and natural gas, oxygen when they put that in the acetylene for welding. Maybe we're looking at a liquid and gas, so water vapor in the air. Liquids and liquids, that one's usually pretty easy. Um, the bottom one, solids and solids, if they're using different metals to make coins. Now, here we're looking at different types of mixtures, and this is really going to look at how big are the particles that are mixed together. So, if it's a suspension, we can see the particles usually. Um, they're big enough that they want to try to settle out to the bottom. You can keep mixing them up and they'll mix kind of evenly, but ultimately they're going to try to separate out. This particle size are usually bigger than 1000 nanometers. A colloid is going to be it's going to be in between the solution and suspension. So they're going to be particles with between 1 nanometer and 1000 nanometers. These are going to be able to pass through a filter, so they're going to be kind of suspended in that solvent. So not a suspension, but they're not going to settle out as the main difference. So here are some examples of colloids. Milk. You've got the fat particles that are mixed in that milk that don't settle out, or that'd be really gross in your milk. Paints have different substances mixed in. So a lot of these things, common to daily life, are going to be colloids. Tyndall effect. When you have light, and typically a flashlight, you can shine through a liquid, and will the light scatter? And so that's going to tell us when we're dealing with the Tyndall effect. So here we can see one, the light seems to pass through, and then the other, just it spreads that light out more. So we can see the Tyndall effect there more with this one. Electrolytes, this is a term that we probably think of when we're thinking of sports drinks. So these are going to have uh, substances in them that can conduct an electric current. In our body, we need electrolytes, but in chemistry, we're thinking of terms of conducting electricity. So they're going to have ionic particles, and those ionic particles, remember, have ions or charged particles, positives and negatives, and that's going to help carry electricity. Non electrolytes are going to be substances that do not have ionic particles, do not conduct electricity.